we are now talking about still our tools, and now about the data portal and some discussion about metadata and research data management. At the end, I will share also some examples on accessing data, either on Zenodo or Adam, the partner project that I told you about before. So a GMAP data portal, now it is. So here's the roadmap for our talk. We talk first about research data management, the portal, and then how you can also play with, if you had never done some Zenodo or published your data package, your geological map, for instance, or really any other scientific data on one of those portals, in particular Zenodo, then I will indicate you how to do that without worrying that much on the quality of the publication, because there is a sandbox there. And then eventually the notebooks I told you about before. As we did before, this presentation here, those slides are the summary of a document that you will find here in the Winter School repository. Everything that I'm talking to you is written down here. Yeah, and as always, if something is missing or you have any doubt, reach out through either the QA here during the presentation or the Discord channel. Right. Okay, cool. So about research data management, this is actually a quite hot topic these days everywhere in science, not only in planetary data science, but in science in general. And it's about sharing your results, sharing your data products, make it not only available, but improve its or their accessibility. So more people can find them, reach them, use them as best as possible. And then there is also the discussion about the data quality. So you have those platforms that we'll talk about in a few seconds that try to guarantee or enforce some data quality or data structure. And a very key point here that nobody likes, most of us don't like, maybe all of us, is the argument about metadata, which it's a big chunk or a discussion or argument feature of those platforms. And also I would list as most important features or trying to be addressed by those platforms, Zenodo is one of them, is to hyperlink those data resources. Right? That's the basis of internet, to hyperlink resources. And we are now at the point that we not only we always wanted to hyperlink data resources, but now we need. And that's, again, then we go back why this is a hot topic, research data management, because the data volume and complexity of our data sets nowadays is quite complex. Sorry for the redundancy, but it's big, it's complex, and we have to use them better, right? So we have a lot of data that was accumulated during ever since or during the last decades that are in let's say hidden from the public, that were stored in let's say universities, hard disks, and we need to make them available so we can not only use them better, the current data, but we can also make use of historical data, right, to complement science, current science. So many platforms are there. It's not plenty, but there are some of them. I would list Zenodo as the best known of them, but maybe I'm biased. It is certainly the #1 in Europe, I dare to say. And surely it's very well known worldwide. Zenodo is our dear friend here. Maybe you came here already. And there are others: Secan, Figshare, Dataverse from Harvard, and Data Hub. There are some of them. We will focus on Zenodo because this is our first choice. It's the one that we are working closely, and not only because, again, it's the best known to us, Zenodo itself, but because in the last year, they released the Zenodo project spin-off, the Invenio research data management software, which is, let's say, it's nowadays, as far as I know, it's the backend running Zenodo. It was a spin-off, an open source project that came out of Zenodo, and nowadays it's available. You can install, you can deploy it on your premises, on your computer, your infrastructure. And if you want to play or to actually do some research, which is our goal here. So we have, let me just remove this thing here. Okay. We have in our premises the so-called data portal. This is an instance of Invenio. Here also you can reach for Invenio if you want to. And we are using Invenio to learn and do our own research on metadata and planetary data publishing, planetary data management. And the reasons we have our own instance is because then we can customize as the research goes, yet we have a like experience, actually the same interface that Zenodo provides for us for the final publication. Let me just go back to my presentation to not lose track of that. So I was there. This is our data portal. So we can come back. This is our data portal. Here you have some links to the search page, which is the same as a blank search here, where you see all the packages that we have published so far. Most of them come from GMAP's parent project that is called, or was called, PlanMap. And here you will see many of the names that are presenting here in this school, and lots of packages that you can effectively use and download them, right? So the feeling is the same as Zenodo. You come here, you reach for the package, you have a nice preview of PDF or browse images, as we call them, and you can eventually download or reach out for the, let's say, the formal publication, the companion article here, for instance. We use this in-venue platform, as I said, to do some research on data publication, and we do that not only by conforming and effectively adjusting our packages to such platforms, but also to use it as a hub for partner projects. For instance, here we decided, so we are building and we want to build up a hub, as I said, to hyperlink other or packages in general, data packages in general of our interest. So we want to build here a hub of packages of interest or partner projects. Here, for example, we decided to publish some of the packages provided by, or some of the maps provided by Astropedia. Here you will not find any data files, because we don't want to take their data out of or from their systems. We just want to hyperlink the resources. So in those cases where you have a metadata only a resource, you will find a link to the for instance, to Astropedia's website, where you go and you find the actual data and more detailed information. So to this point, or to that matter, we use the feature of metadata only package just to hyperlink to other resources or the source publisher. Now, what's about data publishing research and metadata research? Well, the thing here is that and now I go back to the topic of metadata. When we want to publish a data resource, a data product, we need to care about metadata. So for everybody here that don't like or don't care about metadata, hopefully I will convince you that this is a major and very important feature. Metadata is how your data product is found, promotes itself to the world as useful for Mars data researchers or for Martian geologists or Moon. It's through metadata that you say, what is that data product about? What is inside the data package? What is the region on the planet that map is covering? So what are the authors? what are the ancillary data, so on and so forth, right? So you set up a metadata, and for instance, here at in our documentation, I don't know why is not bringing the links. Right. Oh, okay. So it's just slow. In our wiki page that you can access, again, here in our data portal, you find here in the first page, let's say the top links, the most important ones, so to say, or some of the services that relate directly to the data portal. And for instance, here in the wiki page, we have our documentation, and eventually we are talking about metadata. So with the experience from PlanMap project, and also in the long years of collaboration with Astropedia, and not only, but in experience geological data publishing, eventually we came with this model for metadata for the publishing of our geological maps. And there are many fields here. Like we saw before in Astropedia, we don't have as many attributes, but it's pretty complete, or very complete, the set of attributes that we use on GMAP. And it's beautiful. There is only one issue when we are talking about metadata and the research data management platforms. The platforms out there, they are made for general purpose. If you go to general purpose data, well, or a variety of data that is not restricted to a given area of science. It's not specific for planetary data, nor biology or astrophysics or whatever. It's for data in general, and even code and documents alone. So the metadata fields or attributes that you have in Zenodo, when we go there to publish, I want to remove this thing here. Right, okay, so this, so when we go to, Zenodo and we say we want to publish a package, and then you come here, you say, okay, now I'm uploading my data. You will notice, if not yet, if you're a first comer, you will notice that the fields here, there are many, again, very complete from the point of view of metadata fields to describe your package, many stuff, but some things like geological spatial information are not there. It doesn't know about planets. So specific matters, area specific of scientific topics, is not known by those platforms. So that raises an issue when you want to publish your planetary or your geological maps. So how do we fit the metadata, that attributes that are ideal for publishing our data packages, our geological maps, for instance, how do we fit them into Zenodo, for instance? So that is where research in metadata, so to say, or experimentation really comes into the discussion. And this is part of what we do here with Invenio on GMAP, that is to fit those attributes, right? So for one side, and it's not just GMAP metadata, but for instance, we, as I told you before, we are hyperlinking to Astropedia resources. So we also have to fit their attributes there. And why do we want to fit? Because as I said previously, the goal of this metadata is to make data accessible, findable. So ultimately, you want to search for those attributes somehow. Obviously, this also depends on the interface that the platforms provide for their users. So for practical reasons, again, blah, 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 what you may be thinking, and or at least you should, where am I in that discussion? Why should I care? Or what is useful for me? And then here, if during this school, let's say that you produce your geological map at the end of the school or eventually, and you want to go there and publish that on Zenodo or on our data portal. So how do you, and by now you should understand that you have to use metadata. Some fields are mandatory, others not. But how do you do that? How do you fit all that information into, for instance, Zenodo or Invenio? The same. Oh, here is my tip for you. This is my suggested. How do you use? So here on the left side, you have a column of Invenio/Zenodo fields. Those fields are in there. If you look here, if you go there to Zenodo, you will see title, creators, description, additional descriptions, so on and so forth. All those fields on the left side. And then here on the right side, on the description column, is my suggestion of what are the information that you would put on those attributes on, again, Zenodo or Invenio. This is my tip, practical tip for you. Those would make those values, putting those values in there will make your data findable, easily findable through Zenodo or Invenio free text search. You could not, that there is no interface for you to do either through the REST API of Zenodo. There is no way to call for a bounding box region, but still you could put here, that's my suggestion, for example, if we cannot have, we do the best with what we have, right? That's the motto. So you put your bounding box in the description, make sure to put the target body there, put the CRS, please, that your data is in, so people can have a better understanding of the values in your map, so on and so forth, right? So this is, and then here's some tip for about the documents, the actual files. So on the first part, the table is talking about metadata, and then we talk about the files themselves. Right, okay. Put the PDF and images as they are so that we can see the preview, which is super cool, as we saw previously on our data portal. And if you are publishing also raster files, vector data, or other data files, then my suggestion is to encapsulate, package them on a zip file, and then you put the zip file there. Please pay attention to the size of your data. Again, those platforms are not meant to the size of data that we are used to work in planetary data. which are at the order of gigabytes, at least for raster data. Don't do that. Try to reduce, make a small version of your raster data, so with less resolution. So, and put the link to the original source data in your description or in those attributes, the metadata attributes that I suggested. So this is, let's say, the practical, the lesson that I want to give to you for the geological maps that you are going to produce, or any planetary data that you are going to produce, and when you decide to publish that on Zenodo. And then you, if you want to experiment with Zenodo publishing, you should remember that Zenodo data packages are there for life. Once you publish them, you cannot delete them anymore. And that is cool. That is about data persistence. That is about never losing a data resource as soon as internet and and Zenodo service are alive. But it may concern the user that don't want to pollute the Zenodo store, for instance, and that's fine, and that's very well thought. And Zenodo thought about that and provided a sandbox, sandbox.zenodo.org. You go there, all those packages that you are seeing here, those packages will eventually be deleted. Zenodo doesn't say it's going to be deleted or when it's going to be deleted, but it may be deleted. Again, for God's sake, I'm talking about the sandbox, right? Sandbox is there for, so you don't rely for life for a production, let's say, or a serious publication, but you go there, you publish, you do whatever you want, and without major concerns. So use the sandbox on Zenodo to play and understand how is it to publish. Eventually, when you are satisfied with your publication, then you apply the same workflow, the same attributes, the same content on Zenodo.org, the production site. Okay, or otherwise, if you are also willing to have your own instance of and play with your own data management platform, then you can go there to Invenio and deploy on your own. It's not straightforward, but it's a very well done, very well developed software. Shouldn't be very hard. If you are trying that and you have any issues, they have also a Discord channel. And if you have any question, I can eventually help you. I'm also on their Discord channel, and every now and then I am able to help people there. That being said, so we have 20 minutes. That being said, now we go into the examples. Here we have a couple of examples that I want to share with you on data access. Again, everything that is in this presentation, you will find here, and the most updated version of this presentation, and all the links are on our repository. So here I'm going to talk about this. It was here somewhere. Okay. So we talked about Zenodo and the data in there. So here's a cute, maybe, example of accessing data on Zenodo. Again, obviously, we all know, or at least understood by now, that you can go there on Zenodo or on our data portal, for instance, same interface, same thing, and just download stuff, right? Get the data, documents, read, go through the links, so on and so forth. Here I'm talking about programmatic, low-level Python stuff to access data on Zenodo, for instance, right? Because you may be doing, and here is a Jupyter notebook, right? You may be doing some big data processing, and then you have to go through programmatic workflows, or like in this example here, I want to write down a workflow and use that as material for my courses, for this winter school, so on and so forth. So whatever your reason, if you want, here's an example. Here I'm using this Zenodo client library that you find on PyPy. And we are going to use GeoPandas and Raster.io to do some plotting and reprojection here. In this, not getting into much detail, this is, we are going to access Martian craters from a publication of Chiara Marmori, Lagan. And we are talking about this record here of Zenodo. This is a great example, also talking about metadata. This resource here is a great example of great data, great work done by Chiara and Anthony, but poor metadata. So we notice here that we have no description of the content of the package, and that makes our life, if you are doing a programmatic search through Zenodo, that makes our search for data harder, or eventually would be impossible through a programmatic workflow to find this data set. So this is a good example of both worlds. Great data, but poor metadata. Again, trying to convince you, try to put as much metadata, even if not very structured, in the description, so to say, try to put in there so people can make a better understanding of your data product. That being said, let's go for the data, which is, again, a great data set of Martian craters. So we go there. We, here again, not getting into the details, you can follow this notebook to get the technical part. We access the record, we get some metadata, the Zenodo metadata about that. And eventually we get the files that are in there. There is a zip file there, and we list this zip file to see the contents, and eventually we get what is in there, the database of craters in the JSON format. We open that with GeoPandas. We open that, we see here the structure of the data, the data points, position in the craters, and all the other attributes of the database. And then we list the coordinate system that we have in there. Here's the plot of all the craters in lat long. And eventually, we want to overplot that with on top of a base image, right? Of one of those regions, the planet regions. And what we have to do here, they are in different projections, so we have to reproject. So this is the base image that we want to use as base image of our craters plot, and we have to reproject. Giacomo talked about that. Here's also another example of reprojecting the data. Here I'm reprojecting the craters, and then eventually we overplot that. It's a boring plot, maybe slightly shifted. We want to make use of this parameter here, the radius, so we can put not only the central region, the centroid of the craters as given by the geometry, but we want to create a real size plot, or representing the size of the craters on top of the base image. And then here we do that. Here there are some colors to make things look better and clear for the user. So here we have this example on accessing Zenodo data, and obviously that would be boring, super boring. And then obviously later we do this processing here for eventually a nice plot. Then the other example that I have here for you is accessing data from the Adam platform. As I told you, Adam is this project. The Adam Space Explorer was developed during the Neanias project. Neanias project just finished. You have the link here in the document for Neanias, the reference for that. This was a project where we were part of in the planetary group, and we developed together with Mio from Italy this Adam Space Explorer. The Adam Space Explorer is this nice interface where you can, let's see, this here, where you can search for some images covering the planet Mars. Here we have data sets from CTX and HiRISE. You can download that data, it's publicly available. The cool thing about the data in there, apart from all the resources that a Space Explorer provides, you have access. The data that we provide there is science ready. It's already reduced data and in GeoTIFF format. So you don't have to go through data transformations to actually use it. You get it, you use it. It's that simple. And then here in this notebook, I talk about, it's an example of accessing that data. The base image that I used in the Zenodo here, this base image here was taken from Adam. That's the link to our next notebook, which is again an example to accessing data on Adam. You go there, you subscribe to Adam. You can do that to Adam, the Space Explorer. You can do that through all those platforms that we have here in Europe, EduGain, OpenID, or Google and Microsoft. You go there, you get your token, your access key, and you can use the programmatic interface that is the Adam API. Adam API is available on PyPy also. Let me switch here easily, Adam API, and you get there. You access, you go there, start a client. Again, not getting much into the technical details here. You search for a data set. Here I'm going to use the CTX data set. For some reason, I printed all this metadata, although it's ugly. And then you will start your search for some data products. Here you can do bounding box search. You can search for products, regular expression, the name. There are many features, or you can search for incidence angle of the image. All those attributes here you can use to search emission angle, so on and so forth. You can use to search your data on Adam. Eventually, you choose a data product that you want to download. You get it, still using the API provided by Adam. You open it, you visualize it, and it's that simple. You have here already, this is a GeoTIFF image ready to be used. On this notebook, this is what I showed, the simple access. There are other notebooks on the Adam platform that you can reach out. They also have a Jupyter notebook provided by the Nianias infrastructure that you can use to access more exemplary notebooks. Going back to, and to wrap up to our presentation, now suppose, and this is the very last topic, suppose you want to process your data yourself. So the data that we use on Adam, I didn't say that, it comes from USGS, the planetary data system. All the experiments are there. It's a huge archive they have there. You go there. If you don't want to, if you want to go to the source archive of PDS, you will have access to much more data than it's available on Adam. You have access, as Giacomo said, on lunar data or other Mars missions, for example, CRISM, HRSC, so on and so forth. Mercury data, as somebody asked before, Messenger, so on and so forth. You may want to get the data and process the data yourself. Well, NPT is this library that is, so if you want to process Mars data, get access to other experiments of Mars data and process them to the point that you get your GeoTIFF. This NPT library was developed by myself for the Nianias project, and it gets the data from the PDS archives and process that using ISIS and Python tools, ISIS, GDAL, and Python tools. Hence, the notebook, the infrastructure, the processing infrastructure that we put up, that I told about in my previous presentation. So all those Docker containers and this library here, they were developed with the goal to make a stable processing environment so that we can run that not only on our notebook, on our computers for convenience, but also to deploy them on cloud pipelines and make the processing homogeneous and scalable. And this is, the NPT is at the very core of those data processing pipeline. at the back end of Adam, where you can access, you can search for PDS data. You have functions to download and reduce that using, again, ISIS, Python, GDAL, and so on and so forth. And you have a set of functions to do mosaicing using raster.io. There are some functions also using GDAL, although I recommend the modules for raster.io. So if you want to produce your own data, you want to access more data, I can recommend you this library here. And that's it. I guess I forgot nothing. And yeah, so if you have any questions, something is not clear, or you would like to know more, or eventually contribute to all those softwares, packages, and then you are most welcome to reach out here on Discord or through GitHub issues.